Hello to everyone. Um, my name is Carla, and today I'm going to show you basic functionality of Urbano software. So you probably got some information about Urbano software. It's a software for design of sewage and water networks. And today we are going to show how to design sewage network. The software works on top of AutoCAD or Civil 3D, so it is not a standalone software. And when it loads inside, then you will see these additional ribbons and this workspace on the side. But of course, during your work, you can also use all standard functions of AutoCAD or Civil 3D. Besides that, if you use it in Civil 3D, you can read the surface of the terrain from Civil 3D and use it with Urbano elements. Okay, so when you install the software and activate it, so to activate the software, you should go here to Settings, License Manager, and here you will enter the serial number of the license and activate the software online. After that, you can restart the software and it will become active. So when the software is active, you will see this workspace to be white like this, and you will see these buttons on the side. To start working with the software, you have to click on this button on the top here on the top of the screen, New, and here the program will show you these templates that you can use to create new systems. So I'm going to use the template sewage to create a new system. When I create a new system, the program will show me these commands inside of this workspace, inside of this white area. And you can scroll through this workspace with the mouse wheel button. To reach commands, you can click the command with the left mouse button and then use the right mouse button to call the menu. So with this functionality, you can reach other commands directly here in the workspace. Some of the commands are available here on the ribbon, and we placed the most frequently used commands on the ribbon so that you can get them quickly. Let's say to move the nodes, to delete elements, to assign terrain elevation, to assign pipe diameters, and so on. So I'm going to use all these commands today to show you how to define all the data. But first, of course, we have to draw the network. So here you can see an area in this space of drawing, and you can see some polylines and some points that I have here. So I will be using these polylines to convert them to Urbano elements. But before that, I would also like to have some kind of data in my drawing. And to do so, I'm going to use this command to download the data from Google. So here on Tools, I'm going to go to use this command, import from Google Maps. I will zoom so that you can see it better. Import from Google Maps. And the program will show me this window where I will be able to select the coordinate system from which I'm going to download these maps. And if you want to add your own coordinate system, you can pick here and you can type the EPSG code here and call the system. Let's say like this, and you pick, and the program will show you this coordinate system. So I'm going to select this coordinate system from Croatia, as this is the area where we are located in Europe. And I'm going to select this polyline that shows me my working place, right? So in this place, I would like to have the map. So you can draw this polyline freely, however you like. Here I'm going to increase the zoom factor of my maps. I'm going to increase the number of maps to 6, and now my maps will be sharper. I can also import more maps if I want, but it would take more time, so I will use this 6 maps. Also, I'm going to import the points at the same time, and the program will also create the layers for maps and points. I'm going to download 50 by 50 points, which means 2,500 points. To import this data, I will just click import and the program will start importing the maps. And after the program imports the points from the Google, I will be able to create a surface from these points so that we can get a proper terrain information. So as you can see, we have the points here. We have the maps. If I zoom closer, you will see how it looks like. So this will be good enough. So of course, Google Maps are better, more accurate in areas of cities and places where there is a lot of people, right? Because the recordings are better in such places, but you can use it for some kind of preliminary design also if in some areas without so many people, to just get some initial idea about this area and the terrain. However, of course, you will probably have your own data, but for now I will use Google Maps. So to create the surface from these points, I'm going to use Terraform. So I will explain these additional buttons now. So here in this Terraform surface, I can create a new surface and I will call it Google, for example. And now I will be able to import these points from the drawing. To import the points, I'm going to use the command CAD entities. And here you can see here in this first part, I can filter out elements by type. So I would like to deselect all these elements and I would only want to use points. I will do the same with this part and I will only unselect all layers except GM points. So this layer contains my Google points. You can do the same with your data. For example, if you have some text with in your drawing that show you the elevations, you can also use text on a separate layer. You can use polylines, 2D polylines, and so on. So the program offers various possibilities. Also, you can use blocks with attributes if you have such data. Now that I've made this filtering, I will select the entities like this. So I'm going to select the entire area, and as you can see, the program highlights in yellow the points that are placed on this particular layer. Here you can see that the program shows that there were 2,500 points selected. To import these points, I will click import and I will save this. And now you will notice this polygon that is drawn. This polygon represents the surface, so you should not delete it. It should remain in the drawing. Here on the view of surface, I will click on style and I will double click on it to show my surface in triangles. So as you can see, we can see triangles here. And now I will click and show the isometric view to show the surface in 3D view. So here we can see how this surface looks like. I will go back to plan and I will hide the surface now. I will go back to home, to system manager, and I'm back and now I can work with the network. I can build the network. However, I also said that I will explain these additional buttons on the side. So these buttons open additional panels with additional commands. This one will open the panel for Canalis for the design and calculation of sewage networks. And this one opens the panel for Hydra. This is a panel for calculation of water networks. This is the BIM panel where you can export your network to IFC, Navisworks. You can import from LandXML, export to LandXML, import from Civil 3D, export to Civil 3D, and so on. This panel is also, this is an additional panel that is not a part of standard Urbano Ultimate package, but it's also nice, nice features are available here. This is a collaboration panel that contains the possibility to create data shortcuts and also to store your network to the database and share your project and work with others in this manner. There is this last panel, intersection analysis, that is used to analyze clashes and intersections in your network. So there are some settings and the most important, the table of intersections. I will be showing it today. Besides that, here on the bottom, you will see these buttons. This is the catalog editor, where you can reach catalogs of pipes, manholes, prefabricated manhole elements, open channels, trenches, protection pipes, and so on. This button opens the user data, where you can create your own data fields and assign it to elements. And there is this settings button and help and some additional info. Now I will go back to home panel, and now that I have the surface and I have the maps, I can go and I can build the network. To build the network, I'm going to use this draw command, and I'm going to use this option, conversion of CAD elements. With this option, I can easily select the layer like this. I will pick and I will select these elements in plan like this. Okay, I have a double selection turned on. So I'm going to select these elements in plan, and now I will select the entire area, and the program will only take these elements that are placed on the layers that I selected. So now that the elements were selected, I will simply click convert, and I'm going to get the elements of Urbano. Now I'm going to zoom closer, and when I click on this element, you will see that the program created the line on a special layer, sewage sections. So the program created this set of layers, and it placed line elements, sections on a separate layer. Also, if you select this, let's say, sewage manhole or node, this one is stored on the layer sewage nodes main. You will also notice that there are plain nodes, and this means that the program has some kind of hierarchy. So there are plain and main nodes. Main nodes are those where the network starts and where there are connections of 3 or more pipes there. Besides that, plain nodes are those where 2 pipes connect. So secondary nodes, we can say it like that. Now I will close these helping layers to see my network better, but I would also like to see my network with higher layer thickness. So you can also edit it in the layer control, but it is better to edit it directly in this system. So you click here on the system name, right click, edit, and here you will be able to assign some additional settings for your network. For example, we can change the name of the network to sanitary, and we can define pipe reference point. By default, it's set to bottom inner, so this is the pipe point that the program will consider the main point, and it will adjust pipes according to this point. Then we can also define the coordinate system. I will define the same as I did for my Google Maps import. You can define prefixes for names of the elements, and also you can reduce additional points. This option is very useful if you have a very dense surface, a surface with a lot of points. So you can lighten it up in a way, let's say. Now I will click on this second tab, layers, and here I would like to recreate the layer names by using this button, and now the program renames all the layers according to the name of the system. Besides that, I will also increase the line weight for my network, and I'm going to change the color of the main node to, let's say, blue color. Now when I click OK, I will see my network with a better thickness so that you can see it better and follow the course easier. Okay, so now that I did that, I would like to also draw additional elements according to these helping points. And to draw the elements interactively, I'm going to use this command, draw network elements. With this window, I can define various settings, but I will not do it at the moment. I will just draw the network. So I will just press draw, and when I come closer, I will pick these elements and create new elements. Now, if I want to connect to an existing point, existing node in the network, I will use this yellow circle. You will see when I'm away from the node, the circle is not there. But when I approach the node, the circle is there. This is so-called buffer zone, and when you click anywhere inside of this node, the program will automatically connect this element to this node. This is a certain option that is similar like AutoCAD OSNAP. I will draw my network here as well. And here we don't have any node, but we do have the OSNAP of AutoCAD. Well, you should not click here and connect it this way, because then the element will not be connected properly. You should change this parameter to connect elements automatically to section or node, and then the program will connect automatically to this pipe. So when you come closer, you will see this buffer zone. You pick on it, and now the program will connect to this pipe directly, and you will be able to select a new node position. You see that the program created main node now, so that you know that this is a connection, proper connection. I will continue with these options like this. And here you will see this buffer distance. Let's say I can change it to 3 instead of 5. And now you will notice that this buffer zone will be smaller. So it depends on how you would like to connect your elements. You can increase or decrease this buffer zone. And I'm going to finish with this one now, like this. And that's it. So now we have the network. I will close this window, and I will also turn off the layer of these points so that they don't mess up with my drawing. Okay, so I will save this drawing now, and now I would like to show you the tables. So now that we have the network, I will be able to run the tables easily. So to run the table, you just select the table of a certain name. You double click on it with the left mouse button, and you will be able to see the table this way. I will expand it a little bit to show you all the data that is available. And here you will see that all the elements are available. You can sort elements according to any data by simply picking the name of the column. And you can also select elements by using this selection button. So I would like to explain it with details. This is the selection button. So when you expand it, you will see all the available possibilities that you can use to select elements. So with Urbano, you don't select elements by picking on them like what is standard in AutoCAD, but Urbano has its own selection options that you use to perform certain command on these elements. So let's say if I select certain sections like this, let's say this one, this one, this one. So you will notice that the program shows elements with the yellow highlight. And to select the element, you must come closer to highlight it in yellow and click left mouse button to select it. So you don't have to come very close to the element and pick it directly, but you can do it from far away like this, as long as the program shows you these highlights, right? Like this. So now that I selected the elements like this, we will see that there will be less elements in the table. So the program actually filtered out the table and it shows only these elements at the moment. Besides that, you can easily switch to node table or to any type of table by using this window. So let's say you will get the node data very quickly. The names, coordinates, types of nodes, and so on. So what's important about these tables is that tables are configurable, which means that you can configure them and add any data that you want from Urbano and use it, for example, to extract the reports. But of course, I will show it multiple times throughout this course. You can also open tables by using this button on the top. It says Show Data Preview. So we call these tables previews. So when you click on this button, the table will appear here on the bottom, and you will be able to use it and leave it on while you are working with your network. So you can zoom in, zoom out, you can assign some data, edit elements, and so on, and the table will stay on all the time. This is good because you will be able to use the table to, let's say, assign some data, to edit the data. There are some editing options. Let's say for this option, you can edit the data, reset data, and so on. You can easily change the name of the element in the table, and so on and so on. So the tables are similar like these that I've shown before, except they're embedded in the working space. Let's say you can also switch easily to table of nodes, and you can easily select elements, let's say, from node to node. So if you use from node to node selection, you can easily pick any node. You will see that the program shows it in a yellow highlight, and you just drag your mouse like this, and you will be able to pick and select any ending node as long as these elements are selected. So let's say like this. You select it, right click, and you will get these elements. It says here that there are 10 out of 10 nodes selected in this table. If you select all system and switch back to table of pipes, you will see here in the corner that there are just a second. Okay. I will try to come here. Okay, so there one section is selected out of 53. So we have around 2 kilometers of the network. So this way you can also see some kind of info about the length of the network and number of elements. Okay, so now that I've shown you the tables, I will switch to the table of nodes, and now I would like to input the data about the terrain to this element. So to do that, I'm going to use this option, input data, terrain elevation. But this function also is available here on top of the ribbon. So you can easily input data, terrain elevation, and you can reach this window from here. Here there are various options that you can use to input terrain elevations. You can also do it through the table, but I'm going to use this option using digital terrain model. Here, of course, I have to select the network. So I can simply just pick on this yellow button, and the program will say number of selected nodes, 54, right? Okay, just a second. I'm not sure if you see this properly, so I will not be using this Zoom anymore. Okay, so I will be using a function to assign the surface. I will select the entire active system, or I can just pick on this yellow button. And here I will select a surface name, Terraform, which is the name of this panel here, as you can see, Terraform. So this is a Urbano part that will that will help you build the surface. I will select the surface Google, I will press save, and that's it. So now you will see here in the table that the program shows you the values of terrain elevation. So now I will sort according to this terrain elevation, and we will see that the terrain elevation goes from 115 to 107. So it's not a very steep terrain. Okay, now that I have all these elevations, now I would like to draw some labels in the plan. So let me shortly close the table by clicking X, and to draw the labels, I will use labels from this workspace, and there is the label that shows you name of the section, length and diameter, and slope, and so on. So you will see these descriptive names that you will be then using to select the proper label. I will select this one with the length and the diameter for pipes. I will select the entire network, and I will use this button to apply the labels in plan. Now I will come closer to certain pipe and see that the label is here. We still don't have any pipe diameter, and that's why we can only see the length of the pipe at the moment. Besides that, I will also select the label for the nodes, name, terrain, and elevation, and I will apply this label. And now we will see how this label looks like. Of course, we can also turn off the raster to see these labels better. So if we want to move some label, we can use this button from the window of labels like this, or also we can use this button here on the top of the ribbon, Move Labels. You simply select it and select multiple labels like this, either the text or the leader. You use the right click on the mouse, use left click to select some base point and move all labels together. I will also turn off these helping points to see my network better. Okay, so besides defining the labels and showing them in plan, we can also define pipe diameters easily. And to do so, I'm going to use this button on the top of the ribbon, Pipes, or I can reach this command here in Input Data menu, Pipes. So I'm going to input the data about the pipes to my network. And let's say here I can choose between various pipe groups that are available in the catalog. In this case, I'm going to use these PEHD pipes, and I'm going to use pipes of, let's say, 250. I will do it for the entire network, okay? So I will select this yellow button. I just pick on it to select the entire network and press save. Okay, so now that I've assigned some pipe diameters, I will zoom to the pipe network, and we will see that now we do have this value in our label. Besides that, if you turn on the table, so you can use this button here on the top to turn on the table, you will see that if we switch to the table of sections of linear elements, you will see that the program shows the diameters for the entire network to be 250, and they are shown in blue color. It's because the program shows it indicates the recent change in this manner. So you will notice that something is changed by showing the table in the screen. Okay, so besides that, I will of course change pipe diameters and assign some different diameters in different parts of the network. I assigned 250 everywhere, and now I will use this selection option, branches, to assign some other diameters in my network. So you will see here that this selection option, branch, it will connect between two main nodes. So let's say for these two branches, I will assign pipe diameter of 280. I will press save. And for this other branch, I will assign pipe diameter of 315. I will press save. And I will use 355 for the last pipe, the exiting pipe. Besides that, I will also use smaller pipes for these two smaller parts of the network. Now I have pipe diameters. I assign them to the entire network, and you will also notice this yellow highlight that is available here. This is the highlight that goes from the table, comes from the table, and you see the first element is selected, and this is the one that is highlighted. So this highlight comes from this option, mark. So you can choose to mark elements when selected in table, and if you don't mark them, you just choose none. Okay, so I will zoom closer to my elements in the table and in plan, and we will see here now we have elements with diameter of 280, of 315, and at the last point of 355. When I sort my table according to pipe diameters, we will also see that we do have these elements. So now let's say if we choose marking to show marking in plan, if I select elements in the table, we will see that these elements in particular have the diameter of 315. To remove this marking without turning it off, you can use this button, this wipe button, to remove it from the drawing, or type regen in your CAD command line. Now I will apply a thematic map according to the diameters. This is a very nice feature that can help you show the data of diameters in colors. So let's see. You will see here that we have a red diameters of 250, yellow 225, yellow of 250, green 280, light blue in 315, and dark blue in 355. So this can be a nice addition to your project documentation, let's say. Now I will use this thematic map, and I will also show the catalog editor a little bit. So I'm going to use this catalog of pipes to show you how the program creates these pipes and how you can use it. So I showed you how you can assign pipe diameters. So these are the same pipe groups from the catalog, but if you open it in the catalog, then you can easily select certain pipe group and pipe, and you can check each parameter of each pipe. Here on the picture on the right, you will see the color, the picture that represents the property, let's say. Besides that, you can also edit pipes in groups, like you just say right click, edit group data, and the program will open this group view where you can easily change anything. You can change names of the pipes easily and quickly. You can change pipe diameters and so on. So you can easily edit pipe catalog. You can also copy the group of pipes, let's say, and then you can edit it in group view, and let's say keep the nominal diameters and change wall thickness, and then of course you will have to change the inner diameter. But this way we'll get a different set of pipes with different stiffness, let's say. You can also use Excel. Let's say I will select it like this and copy it by using Ctrl+C, and you can paste these data to Excel, and easily paste it to Excel, and you can change something there. Let's say you can change these names and so on. You can define pipe description, valid standard. You can as well change wall thicknesses and use calculation formulas of Excel to recalculate diameters. And then when you do it all that, you just copy the data and position your mouse cursor in the first window here, and you just paste the data and the data will be changed. So it's pretty easy to build your own catalog, to add some additional pipes that you want to add from the producers that you prefer in your countries, and you can then use it easily. Let's say I will call it V2, this pipe group, and when you do it, when you open this function for input pipe data, you can easily find this pipe group and assign pipes from this group to your elements. Okay, so now I will shortly close the table again, and now I will go and draw profiles. I will focus on profiles now. So to draw the profiles, you can use this function, long sections, and to draw them, you simply double click on certain configurations. So we call these configurations, these sub items when you expand and shrink this main command. And this is nothing but a set of stored settings that you can name and you can use in multiple projects. You can change it easily. You can share it with someone and so on. So to draw profiles, you simply double click on this. And now you, of course, have to select elements. As I said already, you always have to use this selection first to run certain command according to Urbano elements. I will select the entire active system, and now you will see that the program shows you some kind of list of elements that will be drawn. These are arrays actually, and when I select them here in these records, you will notice that the program shows you these arrows in the plan. These arrows represent the directions of these elements. So the direction how these elements are drawn, and the direction from starting towards ending element of this particular sequence. I have these marking here, so I will use this button on the top to clear it, clear temporary graphic. So to draw profiles, I will go back to this window and I will just say draw. And here I have to select a certain point where I will draw all these profiles. You will see these yellow rectangles, they represent future profiles. So now that we have the profiles here, you will see how they look like. So this is a standard terrain profile, right? We still don't have any pipe elevation, so the program doesn't show us pipes here yet. But if we zoom closer, we will see that we do have the names of nodes. We have the terrain elevation, the length of the sections, and node station. So now we have to define pipe elevations to see also these values in the tables. Besides that, you can also use this option from node to node to select certain part of the network and draw profiles accordingly. Let's say I will do it like this. I will select this part and I will place this profile here, and also I will use this part to draw profile up to the end. So it's pretty easy to work with these profiles, as you can see. Okay, so now, as I said, I will define pipe elevations here. And to define pipe elevations, there are various options available in Urbano, actually. So you will take the one that works best for you in a certain moment or generally. So to define pipe elevation, pipe level, you can use this button. You can use this ribbon on the top, Urbano long sections and tools, and you can use one of these two commands to draw the pipe level interactively in profile. So you can draw it interactively. You can define it in tables. You can assign it automatically, and I will show it later. But first, let's do it interactively in the profile. So to do it, I will use this option, draw pipe invert, and with this function, let's say if I zoom closer to this profile, I will be able to easily draw pipe level. Here there are some helping lines that I can turn on. Let's say I would like to have my pipe on 1.2 meters of depth and between 1.2 and 3.5. Also, I would like to include the slow step of 1 per mile. I will simply press draw, and to start drawing in a profile, you must hover your mouse over the profile to show this yellow frame. You have to use the left mouse button to register the profile, to enter it, and now you can come closer and just start drawing. You can turn on the snap to snap to this first point, let's say like this, and now you will see that you can snap to this particular element like this. So let's say we will start here, and we will also use the drops as they are. Let's say like this. So here I will use a 5 per mile slope and then a bigger slope. Right click, right click. Okay, so we can see here now that the pipe level has been defined. I defined it with the bottom inner point of the pipe. There is another option with this function. So if you go to the profile where you already have pipe level, you can easily use these quick buttons to change the slope, let's say like this, or even to remove the drop. Let's say if you remove this one, you will have pipes like this. Okay, so this is one way how you can define pipe level in profiles, and there is another way that I will show. Let's say I will zoom to this profile in particular, and I will use this option, input and edit pipe invert. Here I will simply select this profile, and now the program shows me starting point, starting pipe that is selected, and here I can choose between starting and ending node, or I can also do it here by picking it in the profile. And here I can easily define starting depth and let's say ending depth like this. And the program will do it. So the program first shows me these temporary graphics, this green line, and if I apply this solution and close the function, the solution will stay. Okay, so now I will open the table again. I will use this button on top of the workspace to do so. And here in the table of sections, I will sort my elements according to starting and ending invert elevation. And we will see that some of the elements do have elevations and some of them don't. So let's say if I zoom to plan quickly, we will see that this element does have elevations because I defined it. So this obviously belongs to the profile where I did it. And I do have the elevations in tables as well. So let's also move these labels a little bit. And we do have elevations of the terrain and pipe level in these nodes. Now I did it interactively with these interactive tools that are very nice and useful. And now I would like to use this automatic invert calculation. So the function that allows me to define rules to define pipe level for the entire network. So to do that, I will select all these values for starting and ending invert elevation. So I click here and then I use Shift button and click on this last point. And then I will reset this data. So I want to reset the data so that I don't have any data anymore in profiles. And now I will focus on profiles again, and I'm going to define pipe level by using interactive function, not interactive but automatic, sorry. So to do so, I will simply run this configuration as I already mentioned. So you run it with a mouse double click, and here you will have these parameters that you can define. First of all, we can define a minimum depth. So I will define it as 1.2. And I will also define maximum depth as, okay, I will leave it as 4.5. I will define minimum slope as 5 per miles and maximum slope as 80 promiles. I can also choose between different slope options, how the program will define slopes, how it will try to achieve slopes, either to optimize slope for minimum excavation, to favor minimum slope for better hydraulic results, for slower flow, or for following the terrain slope. I will leave the first option as it is. There are some other options as well, but I will not go into too much details. And here I will also change the name of this configuration so that if we want, we can use it later again with these parameters. I will press calculation, and you will notice these blue lines that are shown in profiles. So if I hide this window a little bit, we can come closer and see how the program proposes these pipe levels now according to the automatic parameters. I see the program did it everywhere, so I will simply adopt the solution. It seems fine to me. I will press apply, and now you will immediately notice changes in the tables. I will press save to save the configuration, and now we will see that we do actually have pipe elevations everywhere in all profiles. Now I will shortly close the table again to focus on profiles a little bit. So here you will notice that the program, just a second, I would like to zoom a little bit. Let's say the program shows you this profile. It shows you the pipes, but you will also notice these red vertical lines. So nodes usually have black vertical lines, but these have red. This means that there are some side pipes coming here, connecting here, and that's why we do also have these labels on top of the profile, and we also see the cross section of this incoming pipe here and here, let's say. So now I would like to edit this configuration, the appearance of profile a little bit, and I would like to change the color of the pipe to red. So to do that, I will use this Urbano long sections and tools, and I'm going to use this button, edit configuration, and I'm going to pick on top of this profile, and the program will show me this control where I can edit the profile configuration easily. There is this item that shows you the name of the profile, the scale, the basic part. This is a graphics, how elements will be shown in graphical part, and also we do have these rows that shows us the data. Now to change the pipe color, I will use this button on the left bottom corner of this window, interactive select, and I will select the pipe directly in profile. I will select the graphics of the pipe, right click, and the program will jump immediately to pipes that I will be able to use the color, to change the color of the pipe. Here I can change pipe color mode, so I can change pipe color directly by picking colors, right? But also I can change the pipe color mode to automatic, which means that the program will take the color of the pipe from the plan directly. I will press apply, and now my pipe color will be shown as red. Besides that, I will use this interactive select to hide this window and to zoom a little bit to show you the data about these rows. So we have rows, let's say, plain data nodes name. So first you have the possibility to edit the header, and let's say I will turn off the automatic name, and I will say here manhole number. I will press apply, and the program will immediately change it, as you can see. Then we do have the terrain elevation, and we can change it, let's say, and call it like this, terrain elevation in meter about sea level. Apply, and so on. So you can edit various. You can use various options to edit it. Now, when you pick on the second part of this component, we call this a component, this entire row, you will see here that the data that is shown in this particular row, terrain elevation, is shown in yellow color. So if you pick here, you can easily choose and show some other data. You can either filter the data according to some text, let's say depth. So you can find the let's say lowest reference point depth, and you can use this data instead. Okay, I will not be changing it at the moment. I will just leave it as it is. I will say okay. And now we do have some different profiles indeed. So now that I would like to show you some additional features of the program related to profiles, but also to dynamic model. So you will notice here that we do have some parts of the network where we have a bigger distance between nodes, let's say here, or let's say in some other part, let's say here. So we have a length of pipes of 62, 65, and so on. So now let's say I would like to add some new nodes here to shrink this length, right? To get more revision manholes, maintenance holes. So, but I would also like to show you how the program will automatically add it in the plan as well. So I will split my screen to two parts, to two vertical parts, and now I will also turn on the table to find these elements in plan. So to do so, I will select this option from node to node, because this option works in profiles as well, and I will select this part here from here to here, let's say. Now these elements are selected in table, and now I will switch to another viewport where I will directly zoom to plan to these elements. So let's say we have this first element. I will turn on the marking in profile as well, and we have this first element shown sorry, it's marking both. So I want to mark both in profile and plan. Let's say I will do it for this part first. I will zoom closer and I will zoom closer to this pipe as well. And now I will use this option, edit nodes in longitudinal section, and I will add new nodes directly in longitudinal section in profile. I will just click insert, and I will add, let's say, I will add new node here, and then I will use right click to confirm, and we will see that the node is also added, was also added in plan. So we can see the changes here. We can also do it for these two pipes as well. We can hit the midpoint by using OSNAP of AutoCAD, and we will get some new nodes here. So now I will simply refresh this temporary marking, and I will reselect my elements, and we will see that we do have more sections and more nodes now, of course. So let's say we do have some nodes with a certain, let's say, certain name sequence, N31, N30, N31, N32, and here this one is called N55. So to change it quickly, we can easily go to this interactive tool from the ribbon. You can come closer to the node, and you can use this button to change the name to, let's say, N31A. And on right click, the program will change it, and it will be changed also in profile. So this way, the program actually takes care of the changes so that you don't have to. So this is what we call the dynamic model, the behavior of the program, where whatever you change in plan, it will be reflected in profiles immediately if you do have profiles, and whatever you do in profiles, it will be reflected directly to plan and also to tables. So I will switch to node geometry to show you. Let's say if we scroll a little bit, we will see that this node N31A is shown in blue color, so it means that this was something that was changed in the last step. Okay, so I will go back to a single viewport now, and I'm going to define manholes now. So to define manholes, I will use this command, input data manholes, from the top of the workspace. So there are these nice pictures that describe the functions. And here you will notice that this window is different than the one when you define pipe diameters. It's because for manholes there are more parameters that needs to be defined. So first of all, you can select here the manhole type that you prefer from your catalog. So let's say I will use this one, and the program will show you this picture to show you how does this manhole look like. But besides that, you can also define these geometry data that is turned on by default. So you can turn it on and off. And you can define the cover elevation above the terrain. Let's say if you made such a design that you have, let's say, terrain number 1, terrain number 2, or existing and projected ground and so on. Depends how you call it. So you can do it this way. You can increase the cover elevation of the manhole. You can also increase the depth of the manhole below the pipe so that it's not like 0, but there is some additional depth underneath. And also you can define how you will calculate the depth of the manhole from bottom outside edge of pipe, from inside edge, or by using absolute elevation or the depth below the terrain. I will leave the first option on as this is the most commonly used option. I will select the entire network like this, and I will just press save. So now when I do it, I will zoom closer to profiles, and we will see that the manholes are there. So the program assigned them. And now let's say if we would like to make some change for a certain part of the network, let's say this one. If I would like to flatten out this pipe to have one single slope, I will use this input and edit pipe invert option like this, and also I will draw the bottom point of the manhole like this. So to select certain part, you can just pick this blue arrows to start with to select starting and ending point. You can also see this arrow that is shown, how the program indicates to you that there are some changes. So also you will see this red line. This is the connection with the next section, so we can turn it off easily. And we can easily change the slope of this part. So now our manhole should be deeper here, and you will see how the program did it. So as soon as the pipe level is changed, that is connected to the manhole, of course, the manhole will also change. Its bottom will adopt to this pipe level. Okay, so now we have our network, and now I would also like to zoom shortly to labels to show you how you can, let's say, add some data to labels, or how you can change the labels a little bit. I will change this label, and let's say I would like to change it so that my pipe diameter is shown like this, the N. And I will also turn off this precision, and also I will increase the text height for all these labels like this. I will do the same for the label of nodes. I will edit it easily. I will do the same, and also in this case I will add the data about manhole. So to add some data to your configuration of any kind, you just pick this button, and you select some data, let's say manhole name. So you can select it like this. You apply it, and you will get the name of the manhole shown here. So of course you will have to move your labels a little bit, not to overlap, or you can even push it on the other side, and so on. Okay, so now we do have our network. I will save this drawing, and now I would like to show you an additional mm, thing that is important in Urbano, and this is the functionality related uh, to import export of data and elements from various outer files. So Urbano has different options. You can import the data basically in the most basic way. You can import it from text files, but you can also import it from shape files, which is very important when you have proper GIS systems and you want to use them. You can import the data from databases. You can import from, let's say, Land XML, from Civil 3D, from INP files, both for water and network, um, and so on. And you can also export networks in all those formats, but also you can export it to IFC and NVC that I also mentioned at the beginning. So in this drawing, I will import additional network from shape files, and we will say that this is an existing water network that is available for this project. So we do have the records where the existing water network is. So we will add it to control the positions of our sewage network elements. I will close the table for now, and now I will create a new network of a water type. So I could do it by using this button again to creating it from the system template, but in this case I'm going to use my own system template that I created because I made some changes of how the elements look like and so on. So you can create your own template of your system by saying to the program, save as template. So if you change your tables, you create your own labels, you define profiles, change them, and so on. You can easily save all these settings as a separate template and use them in your other project. So that's why what I'm going to use with my water template. I will create a system based on this template. I will adopt the names of layers, and I will now have my new network here. So now you will see it says water. So if I switch to this window, you will see here that I can switch from water to sanitary network, but now here water is the active system, and this way we can easily check which system is currently the one that we are editing, right? So the one that we want to edit must be set as active. Okay, I don't have anything yet in my water network, but now I'm about to edit. To edit, I will use this import option, and I'm going to use shape import tool. So now I will have to find the folder where I do have these shape files. So it's here, and I'm going to use the drag and drop technology to drop this shape file here into this field of sections, and I will drop this nodes shape file into this field of nodes. So now, before importing this data, I also have to tell to the program which data from the source, from shape files, corresponds with the data from Urbano. So now I do have this data in my shape files. I will use the name to connect it with the name from Urbano. It says target data. It is actually Urbano data. So I will use this button to link this to data. So the program will simply take the name of this element and have it in Urbano. Also, I will use starting level and ending level of the pipe. Also here there are some custom data that we can use to import any kind of data into these fields. These are like blank fields. I will not use them. I will simply add this material and pipe diameter as user data. So if you click this button, there is a little man here drawn. And when I click on this button, we will get this additional user data. As you can see, the program creates this data, material, and pipe diameter. We will use this data to assign the same pipe diameters to our elements by using standard Urbano functions. Now I will switch to nodes and I will connect the name of the node to the name in Urbano, the terrain elevation with the terrain elevation in Urbano. And now I also have the data about manholes. So I will assign manhole name, node type, and manhole length and width to my elements. I will click OK, and now I have to run this import. I will double click on it, and now I will use this button, Draw Convex Hull, to draw the polygon that shows me the area where my network is located. So this is a nice feature. When I press the import button, the program will draw all the elements of water network, and they will be available as a standard network in Urbano. I can lose this polygon now, and I will zoom closer to see these elements. So we will also notice that in some places, of course, this water network intersects with the sanitary network that we are working on. So of course we will be able to find where these places are, except by just looking at it. There is this intersection analysis tool for that. However, first I would like to see the data about my water network. So I will open these tables, and we will see this section geometry table. We do have the starting and ending node, the length, the elevations, but we do not have the diameters. This is because I added these diameters and material as a user data that I will show. So here, when you click on this little man button, you will see here that the program creates this additional data from shapefiles that you can then use. You can edit this data and so on, but the program imported it, created it, and now you can use it to your tables to get the site of this data. So to add the data to the tables, you can easily say edit. You edit the table the same way as I edited the label, and you use the same button to add new data. You say select data, and as I said before, there is a lot of data that you can reach in Urbano. If you start typing anything, let's say slope, you can get the slope in your table, right? So you just double click on it, it will jump on the right, and it will be added to the table. Now I will remove it, and here you will notice that there is a special group, user data, that is visibly different so that you can easily see it. And here I have these two data that I added from shapefiles, material and pipe diameter. I will say OK and OK. And now here we have the data from shapefiles. So we have the diameters, the material, and now I will use these data to assign diameters to my network. So it's polyethylene high density pipe, and we do have a pipe diameter of 160. So to assign this diameter easily and quickly, we can simply select the same scope, the same area, here in this column for the diameter. So this is a column from Urbano, and you can easily say to the program, right click, edit data, and the program will immediately open the catalog that you can use to assign these pipe diameters. So I will do the same. I just have to look until here. Okay, so I will edit it and assign 180 pipes here. Then I will do the same for 200 pipes. Let's say up to here. Edit. You can change it here, 200. And it doesn't matter. If you make a mistake, you can just edit it again. So it's pretty easy to work with the program. Then we have the 280 pipes. I will edit them as well. And I will use 315 pipes. Okay, now up to here. I will edit them. And we have a few more pipes to add. Okay, so now we do have pipe diameters. And now I will shrink the table. I can use this standard window shrink tool. And now I will draw profiles of my water network. I will simply double click on this water network configuration. I will select the entire active system and I will press draw to draw all these elements. So if I zoom closer, we will notice here that we do have pipes and pipe diameters, but we also do have the indication of where this sanitary network is. So this is important. We do have the same data in our profile of sanitary networks. So we can see here that the water network pipes are here, and we can see how it looks like. So now I would like to run the intersection analysis. However, I do have the data about manholes and so on. So to skip this step to assign all these data from shapefiles, I will simply go to the similar drawing that I prepared, where I'm going to just run this intersection analysis. So we have the same or more or less similar data here. So I would also like to zoom closer, and here I have my network shown in 2D like this. How I did it? Well, I will do it now for water network as well, and I will do it by using this plan style. So I will double click on it and I will select the entire network and press apply. So you are able to create your own style, your own appearance of the network. And here you can also edit it. So let's say I will use this button here on top to get some info about the manholes for my water network. So I do have the manhole here, but here I don't have any manhole. Here I have them. However, these nodes are shown with a bigger circle, so I would like to edit it in this style. So to do that, I will simply go to edit the style and I will change the appearance of these nodes. So here you can define how the program will show you the nodes. You can show the top view. This is like a 2D graphics, a real size. But if you don't have the manhole in certain node, the program will show you blocks. So that's why I would like to change blocks for those nodes that don't have any manhole. I will select this button to change the scale of this little circle that shows us our blocks. And also here in sections, you can choose how to show your pipes. You can show it as a line, as pipe contour. It means a pipe in real size, 2D, and also 3D. I will update this style, and now the program will change the appearance of my nodes. So now we will only have manholes, and for nodes there will be a small circle. Okay, so now that I have these networks shown in 2D, I will go to this intersection analysis to show the places where there are real intersections. So I'm going to click this intersection preview. And here I can see that there are many places where we have intersections. So you can see the data, pipe with pipe, sanitary network with water network. You even have the names of these elements, the diameters of these elements, and the relative position. I will shortly close the table, and we can see here that the program automatically zooms to this part where we have the intersection. But for now, I would like to edit the preview. So I will edit this table this similar manner that I did before. Let's say I will change um, this string is too long, so I will change it to the n, and I will change here, let's say, element, system, and the rest is okay. So I will click OK, and when I run the table again, we will have much smaller table like this. So of course, I mentioned when you zoom, when you click according to these records, the program will zoom to these intersections in plan automatically. However, you can also immediately zoom to profile like this. You can also choose the profile where you will zoom to. So we will see these elements in profile directly. Now I would also like to show only collisions. So only the pipes where there is a real collision between them. So pipe with pipe collides here. And if we come closer and zoom to the profile, we will notice that our pipe is here. Sometimes this graphics needs to be regenerated a little bit. Now we can see a proper place of our intersection. So of course, we will have to change the placement of sanitary pipe to avoid water pipe. So I will simply move this window a little bit, and I will focus on this profile, and I will go to input and edit pipe invert once more to change this pipe level. So I will select this part. Let's say I have to select the profile first. Sorry. Okay. So this is a common problem. So now my water network is defined as active, and I have to switch to sanitary network to be able to edit the elements of sanitary network. So let's continue. Now I did it, and now I will select these elements. So let's say I will select element from here to here, and now I will push my network, my pipe, sanitary pipe, a little bit down. Also, I will tell to the program to change the next section. I will press apply, and now our pipe is far away from the water pipe. Now this pipe is backwards. It has a negative slope. So if we go to the next pipe, we will notice that the slope is negative. However, we can easily select a sequence of elements that we would like to that we would like to flatten to create the same slope altogether, and I will press apply, and the program will do it. Okay, you will notice that this profile is grayed out when you are using this function. This is intentional, and that's why to go back and to see this profile as it is again, you have to close this function. Now we still have one more clash, and when I click on it again in the table, we will notice it here. So now, besides the vertical clash, that is obvious, we do have the clash with pipe and manhole, obviously, right? So there is also a list of clashes between pipes and manholes. I will get to that, but now I will focus on this one, and I have to zoom out a little bit to see how these pipes are located. So the existing pipes or water network are here, and I will have to move the sanitary network to avoid this clash of pipe with manhole. So I will move the node of sanitary network like this. I will use the table, and I will push it here. So now we will probably have to move one more to avoid colliding with the water pipe that is existing. So now our clashes are gone, but we still have the clashes between pipes and manholes. So let's see how does it look like. We can see it here, and to avoid it, of course, we will have to move our sewage network. So I will move this node here, but I will also have to move it here. As I'm moving these elements, you probably notice that there are changes in this table, and now there are less clashes here. Okay, I will push this back to the center of the road, and now I will go back to these clashes. We can see it here. We can also see it in 3D. So the program shows us these mesh elements, and we can see it easily. Again, I will move this element a little bit on the right, and now this clash is gone. I will continue, and here we have to check it a little bit. I think I made a mistake when drawing the network previously, and we can also move this node to be a little bit more far away from the water pipe. And we have only one clash left. And in this case, I will simply move it here. So you see how the program also updates the labels. I will close these helping lines as well. And we can see that our network has been created properly according to this existing water networks. Okay, so now that we do have everything defined, we defined everything properly, we will also define manhole schemas. Let's say I will use this configuration to draw manhole schemas by simply double clicking on it, selecting the entire network and pressing draw. So now I will place my manhole schemas somewhere in the drawing, and if I zoom closer, we will see that the program shows us all the data that is relevant for a manhole, and also if we have 3 or more pipes, the program will also show us outlets and inlets and all its data. Besides that, let me save this drawing. Besides that, you can also easily generate a report of manholes by using this XLS manhole data export. You can execute it and immediately open the document to show the data of manholes. So first part shows you the data of manholes. Second part shows you the data of outlet pipe. So it's the first one that is shown. Then we have the data about inlet pipes. And as much inlet pipes there are, the program will show them. What's nice is that the program will show you this angle from the outlet, and this is the angle. Let's say I will close this one. This is the angle that, let's say, is shown from the outlet. Let's say if this is the outlet, the program will show you the angle for each pipe, considering the outlet and going in the clockwise direction. Okay. So I created the report, and now I would also like to show you how you can define data for calculating excavation and trench layers. So to do that, you have to define a trench. To define it, you go to input data, trenches, and here the program will offer you the trenches available in the catalog. So you can choose between some of these trenches. I will use the 90 degrees trench, vertical trench, and I will select it for the entire network. Now you can define various trenches for various parts of the network, but usually it's standard to have similar trench. And I will show the catalog of trenches to show you which trenches are available. So we have single trench where you can define the angles of the sides. You can decide to calculate the width or define the width by yourself. You can define the bedding thickness, the pipe angle that is embedded in the bedding, the filling height above the pipe, and the bedding material. And also, in cases that you have the vertical trench, you can also use formwork. You can also choose the double trench if you prefer, or if your project requires this way. Okay, so besides the trench, I would also like to define the top layers for my network. So let's say I will zoom to this profile to show you the trench, the bedding that is shown in the profile. And I would also like to show you how you can define these top layers, upper layers. To do so, I will go here and say upper layers. And I will assign asphalt upper layer for the entire network, because this is a small city where we will build our sanitary network. But there are some places where there is no asphalt, so we will do it differently, and we will assign this other part of top layer from point to point in the network, so you don't have to have the nodes everywhere to snap to them. You can also choose these data to do it from point to point. And now I will zoom to the profile and show you how does it look like. Okay, just a second, let me see, maybe I didn't select it properly. Okay, I will do it from here to here, and I will press save. Okay, let's zoom to this particular part. So I will open the table to select this pipe and to zoom to this profile. So okay, this data is here. We can see that there are different upper layers available in this drawing. Okay, so now that we do have these elements, I can easily draw cross sections to show you how they look like. So we can also turn on the labels of these cross sections and use interactive tool to pick certain points of the network. Let's say I will do it along this array, and we will select few of these places to draw these cross sections. When I press draw, I will be able to choose the place where to paste these cross sections, and we will see how they look like. So the program will show you um, the dimensions, and it will show you the layers and the top layers of the cross sections. Now, of course, the most important thing is the excavation report. So you can configure it as well as you can do for other things, as you can see here. But also to generate it, you have to double click on it, select the entire network, and as you can see, the program will show it to you according to the arrays. And when you press save, the program will calculate the values, and it will generate the Excel file that you can open immediately. And here you will get the data about the excavation volume, excavation zones from 1 to 2 meters, from 2 to 5 meters, I don't know, it depends on how you define it. You will get the value of upper layers, the volume without the upper layers, sand, concrete bedding, pipe volume, sand backfill, and so on. So for every array, the program will get a total sum of the data, the quantities, and you will see it for each array of your network. And at the end, the program will do it for the entire project. Okay, so now that we created all these detailed drawings, profiles, we defined elevations and everything. So let's say this is done and we have everything, we have the reports. We can also extract reports from the tables, as I mentioned before. Let's say you just sort your network according to the names. You select it like this by picking on this corner here and copying the data and pasting it to Excel, let's say like this. So you can get reports very easily by simply copying the data from the tables. You can also create tables directly in the drawing by selecting the entire table scope and say draw cat table, and the program will offer this table usually after you use thematic maps. So this is a very nicely configured table where you can get all the data. This is a real AutoCAD table, so you can use it to add some formulas to it if you want, or you can export it to a CSV file or whatever. Okay, so now, as I said, as we have all these elements and detailed drawings, we would also like to export our network in 3D in IFC. So first of all, we can show our network in 3D directly in CAD by showing solids. And to do that, we will use this 3D style. So but I would like to do it at once for both networks, and to do so I will use this multi-system input button on the top, where I can label elements for all networks at once, and I can also apply different style for all my networks at once. So I will choose this 3D style. Of course, it has to be available in the drawing, but it usually is because this is the default. And when you come closer, you will notice that these elements are actually 3D solids. So if I switch to 3D view, okay, my picture got messed up. Okay, I will turn off the map and you will be able to see the elements in 3D directly like this. So let's say if we select these elements and if we use Object Viewer of Civil 3D, we will see that these elements are actually not colliding. So our clash analysis was very, very useful. Now, if this happens, if the picture is gone, you can easily open the table of Urbano. You just say zoom to plan in the table and you are back. Now, I would like to also export networks to IFC, as I mentioned before. And to do that, I will use this BIM panel. And first, I'm going to configure the data to export to IFC. So I do have this geometry data. So it works in a similar manner as the table that I've shown previously. So you can create your own table. You can add some data that you want in your own table, node type, array, starting node name, ending node name, and so on. So you can create your own table. This is also the first thing that is important. I will be using these standard tables, and let's say I will call them 01 Urbano, geometry data, and excavation data as 02 Urbano. So you can also name them with alphabetical order so that when you see it in IFC, you can get this data properly. Okay, we also have tables with sewage and water hydraulics, but I will not be showing it in this course. So for now, I will not focus on this. I will close the table and now I will go to IFC export, where I'm going to select elements that I want to export, and these will be systems and the DTM, the surface. So I can export both systems, even if my water network is an existing network. Still, I want to see it in 3D, so I can also export it. Now I would like to also export the data, and here the program the program doesn't show me the list of data, but the groups of data that I defined previously. I will select geometry data for all networks, and for sanitary network only, I will select this excavation data because I created this data for sanitary network only. Water network will not have this data because it's an existing network. Now I will export all these networks in the same file, and also I will export elements even if they don't have let's say the 3D elements, manholes or pipes. I will also set the base point, let's say in this bottom left corner. This IFC base point is very useful actually because if you are assembling your model in Revit, let's say, then this is important because this resembles to Revit project base point. This is a feature that has been requested by many customers, and we added this feature. Now I will export this IFC file, and I'm going to show it in a software that is called BIM Vision. Okay, so the file is written as we can see, and in the meantime I will open BIM Vision software. It's a free software for viewing IFC files where you can then check if your IFC is correct. So in this case I will open the IFC file that I've just created at this moment. This one, I will open it and we will be able to see elements and the data. So I can see that the surface, I will hide it quickly, and now I can, let's say, click to some element and zoom to it. So if I select it, you will see here on the right part the data from Urbano 01U Urbano, geometry data, manhole bottom elevation, system name, terrain elevation, coordinates, and so on. And you can see the pipes data as well, where the pipes also have this excavation data. For water pipes, you will see only this basic geometry data that I selected. So, okay, that would be it for today. And now we will switch to Q&A.